Okay, one of the main things we did in Chapter 6 is we looked at solving equations by graphing. When solving equations by graphing, you're looking for the zero values. Example, if I have something that looks like this, where it crosses at 0 and 4, then I know that I have two answers, x equals 0 and x equals 4. Now, aside from graphing on your calculator and pressing second trace, you could also solve by factoring and setting each factor equal to 0. And then option 2 would be using your calculator and finding all those 0 values. So we're going to look at example 1 here, and we're going to look at it in both of those options. So option 1 is solved by factoring. Factor. Now the first step you have to do, whether you're solving by factoring or graphing, is to set the equation equal to 0. So if I have this equation, I first need to subtract the 9x to the other side to give me 3x cubed minus 6x squared minus 9x is equal to 0. Then in factoring, you look for the GCF. So what's common in every term would be 3x. Take that out, and that leaves me with x squared minus 2x minus 3 is equal to 0. In factoring, I still want to see if I can factor the inside, so I ask what multiplies to be negative 3 but adds up to be negative 2, and that would be negative 3 and positive 1. Now since x squared has no coefficient, I can use my choices, negative 3 and 1 in my factors, x minus 3, x plus 1 is equal to 0, and I still have that 3x on the outside. Now in solving, I set each factor equal to 0, and I solve. So I do that, and the first one, subtract the 1, I get x to equal negative 1. The second one, add the 3, I get x to equal 3. The last one, divide by 3, and I find x to equal 0. So I have 0, 3, negative 1. Now let's check ourselves. Because this started off as a cubic, therefore we know we should have had 3 answers for x. So I take a look at that. Yes, I have 1, I have 2, and I have 3. So when I graph this, if I tried to solve with my graphing calculator, option 2 mentioned above, then I know that I should have x 0 values. So this would be my x-axis at 0, negative 1, and positive 3. So I'm going to show you the graphing calculator. I'm going to plug that in, y equals 3x cubed minus 6x squared minus 9x, and I graph it, and 1, 2, 3. Yes, I have a 0 at negative 1, 0, and positive 3. So I could use my graphing calculator to solve this as well, and I find my 3 0 values, x equals negative 1, x equals 0, and x equals 3. So looking at that, you kind of have two options. Now, what we're going to be looking at in today's lesson is when can you not use your graphing calculator to solve. So I know I'm kind of skimming over this, but if I show you the back page, if I gave you example 5 and I said solve using your graphing calculator, then you would plug that in for y, x cubed minus 8, and you would find there's only one 0 value at a positive 2. Now wait a minute, this is a cubic, so therefore there should be 3 answers. Because only one of them shows up, x equals 2, that means that this problem cannot be solved using your graphing calculator. It can only be solved by factoring. Now, how do we factor something that looks like that, x cubed minus 8? Well, we have a formula that works for the difference of two perfect cubes and the sum of two perfect cubes. And that's what you see in the next piece. So I am skipping example 2, but I'm going down to this new formula that we need. If you have the sum of two perfect cubes, one number cubed plus another number cubed, then you use this formula. It equals the cubed roots, which would be a plus b, times a squared minus ab plus b squared. In the same way, if you have the difference of two perfect cubes, you factor down in this way. A minus b times a squared plus ab plus b squared. So let's see if we can use these formulas to factor the bottom examples. So example 3, I have x cubed plus 8, and I need to factor that. Well, first I need to see what two cubes am I working with. I'm working with x cubed, and I'm working with 2 cubed, because 2 times 2 times 2 would give me 8. Now this is the sum of two perfect cubes, and I'm going to use the sum of two cubes formula. So that formula is equal to, if you have a cubed plus b cubed, then it's equal to, oops, I'll put it up here, a plus b times a squared minus ab plus b squared. So what are my a and what are my b values? A was equal to x, that's what I was cubing for the first term, and b is equal to 2. So in my factors, I'm going to plug in x as a, b as 2. So I have x plus 2 times x is a, so I have x squared minus a was 2 times x, plus b is 2. So I have 2, and then I square it. So this factors down to just x plus 2 times x squared minus 2x plus 2 squared, which is 4. And that's what it is when you factor it. So let's try another example. I'm going to add one down here. If I ask you factor x cubed plus 27, first thing you have to determine is what are your two cubes that you're working with. X cubed is the first one, and what times what times what would give me 27? That would be 3 cubed. So I'm going to plug this in as a and plug this in as b and see what does it factor down into. Now I'm going to give you a second. I want you to try this one on your own, and then I'll give you a few helpful hints of how to memorize that formula. Okay, so go ahead and do that, and we'll start up in a second.